So, if we're going to do this, I've got a right angle triangle. Talk me through the process. What should I do first? SOHCAHTOA, let's write SOHCAHTOA down. So I'm going to do SOHCAHTOA. Next. Theta. Opposite. Adjacent. Hypotenuse. Then we go through one of the most important bits, which is getting things correct in that list. So in this case, theta is now the x. Theta is x this time, not a value that we know. What's the opposite side to that angle?
5 centimeters.
That's the 5, so that's the opposite side, so I can do 5 there. The adjacent side is the one that makes with the angle, next to the angle, it's not the longest, so that's 12.5. And the hypotenuse, and that's the adjacent, therefore this is the hypotenuse, but we don't know it and we're not asked to find it. So we'll cross that out. What does that mean about our choice of ratio? Which one can we use? TOA, because this has got a H, this has got a H, so we have to cross both of them out. We can't use them. So we're going to use the tangent of the angle is equal to the opposite side divided by the adjacent. Right. We do now. So let's put the values in. So tangent of x is equal to 5 divided by 12. Okay, I'll pause. Yeah, we could convert that. That's not a problem. So let's do this bit. So the tangent of x is equal to, so remember, let's use our calculator, 5 divided by 12.5, enter, I get 0.4. Not really clear on my screen because it's just a bit, so we get the idea. 0.4? Yeah?
Wait, is the big blue bar the different bar?
The what? The blue bar is the enter, yeah? Hence practice, isn't it?
Yeah, I got it.
0.4? Yeah? What's up, Alistair? Going left and right like on a computer. If you want to change something in your what you put in, yeah? Right, so we get 0.4 there. Alright, what do we do now? Any ideas? Sorry, tangent of 0.4. I get why you say that, but it can't be that because its tangent of x is 0.4. Alright? Now here's a common mistake. What people do is they think tan is times by x, so they divide by tan. But it's not tan times x, is it? It's tan of x. So all I know is that x has to be an angle, and the ratio that goes with that angle, if you remember all that similar triangle stuff, is 0.4. So there's no way of me doing a divide by tan, or I definitely don't want to do tan of 0.4 because it's tan of x. But everything in mathematics has an inverse, right? And we do have it. We're relying on our calculator. And what we're going to do, this, just to write it out, is the tangent of x is equal to 0.4. And what we're going to do is we're going to do x is equal to the inverse tangent of 0.4. Alright? Because everything has its opposite. If it wasn't multiply, we'd divide. Divide is the inverse of multiply. What's the inverse of subtracting? Addition. So we're going to, instead of doing tangent of x, we are going to do the inverse tangent of 0.4. All right? We're only going to do that on our calculator. And what it looks like, tangent of x looks like that. Any ideas what you think the inverse tangent might look like? Yeah, it looks like this. All right? It looks like to the power of -1. It isn't, because it's not a multiply, it's an inverse notation. So how are we going to do that on our calculator? Well, again, if we're back to this, I'm going to, again, you're on the video, you won't see this, but up here, look, we've got main, ABC, and function. We've got sine, cosine, and tangent already there. I don't want tangent, but if I click function, you'll notice that now, here, look, I've got the inverse tangent. So if I press that, and I've got my answer before, so I can just write, I don't even need to remember it. But where's my 0 point? How can I do that? Well, you need to go back to main, and now I can type in 0.4. Okay? There is also the option to just put answer in there. Right? And then I can close my brackets, and let's press enter, and I get the answer. 21.8, which means that the angle x degrees is, what did I say, 21.801 degrees, but you'll notice it says 1 decimal place, so that's going to be 21.8 degrees. Does that seem reasonable? 20-degree angle? It's a bit harder to recognise in real life, but if it was 0 point something, we might have done something wrong. It looks like a reasonable angle. Yeah. Well, as when we had it up, there is that option while we were typing, it has a keyboard. But I wouldn't worry about it too much. Right. How do you feel about that? So the final bit, all right, the final bit where people go wrong is doing this bit, the inverse tangent. Right, that's where this is different.
So we use the inverse tangent if the angle is just x.
Yeah, so use the inverse sine, cos, tan when you want to find the angle. Okay? So I believe there's lots of questions now. You can go to the next one, yours. So after you've identified the hypotenuse, look at the angle that you're being asked to use, not the 90, the angle, and the one that makes the angle with the hypotenuse is next to it, that is your adjacent side. Right? Always, doesn't matter what rotation or anything, it doesn't have to be the bottom one, top one, or anything. So the hypotenuse and the adjacent make the angle that you're. Now here's a tip, guys, for the calculator. Do you remember last time we turned this into a decimal? Yeah, wrote it down. The ratio here, the division, we did the division, yeah? Remember doing that? I'll look at my screen in a second. So let me show you this. Once I've written, have you got this far as well, yeah? I've done this. So we then write x equals the inverse cosine of, well, I haven't turned it into a decimal yet, I'm just going to write that. Are you okay with that? Now, the reason why that's quite good is because I can now put that into my calculator. Okay? So I can actually go function, inverse cosine, and And if you actually press divide first, look, it gives you a fraction option. And you just put your numbers in. Can you tell me the numbers again? 6.4, and then click 9.6. So I don't have to do anything other than that. And here's where I use my arrow, look. Get out of that. Now, look, you can see the answers already done. That was it. So I didn't need to write a decimal. So, for instance, did you have to round your number before you did that?
This one?
Yeah. So did you do 6.4 divided by 9.6 and have to round that? Yeah. So in this case, I haven't had to round that number because it just goes straight in the calculator, right? Makes it easier. And then my answer is 48.189. So that's right. So x is 48.189. Sorry, what did you say? So 6.4, 9.6. 6.4, right, so here's the thing. No, well that's what I'm just trying to tell you. So if I did 6.4 divided by 9.6, press enter, I get that, yeah? Now I've got to do the inverse cosine of, well, how do I put all of that in? Did you round it to 0.67, for instance? 0.66. Okay, now is that correct rounding? Okay, now that is not the same as that, right? I'm not saying it's wrong, it's not exactly the same, is it? Right, so what will happen if I use that number instead of that number? My degree angle will be slightly different. Are you wrong?
That's wrong.
What do you mean?
What's the angle?
Oh, no, look, we've got to give our answer to one decimal place. Now, if I did this, basically what I've done is I've reduced the accuracy of my answer. I'm not incorrect, I'm less accurate. Now look what happens if I do this, look. I believe I can press, what if I do 6, look at the answer now. Just having another 6. What about another one? Another one, another one. Or you do what I did before and not do it at all, leave it as the division. But do you see that if well, let's just check something, look. Would I have been closer if I'd have done 0.67? Still not quite the same, still rounded. So actually in that case, because I'm on a computer, I could just put a load of 6s in and get closer rather than rounding it. Or, like I said, don't even turn it into a decimal in the first place, because I'm on a computer, I don't need to. Make sense? So that's why your answer, so I would now have 48.2, but yours was 48 point, now that's half a degree different. Big difference. But actually, it could be in real life sense. How do you feel about that? Next one now? Go for it.